So thanks everyone for coming. My name is Jorge. I work for Sysdig, and we originally created this project called Sysdig Falco, and I'll go through Falco in a second. But first, I want to cover or to give you a little bit of context about container security. So if you're trying to implement container security, there is at least 3 different layers where you can take different actions. You need to secure your infrastructure. You need to adopt secure processes on how you build your containers. And you need to look at what's happening on production when the container has started to run. We are going to look at the 3 different phases. And okay, perfect. So if you're looking at infrastructure security, you need to look at the network, storage, host, cluster, container runtime. And you're probably familiar with tools for this. You have SE-Linux, you have Docker Bench, you have a number of different software-defined network layers like Weave, Calico. Even Kubernetes has a number of security security features. But typically, when you deploy applications in Kubernetes or in containers, you come up with a structure like this, where you have the basics of your hardware, your host, your clusters, your containers, and inside the containers, a number of components, libraries, application, etc. If you want to secure the build or the processes on how you build your containers, first you need to make sure that the software that's actually running inside those containers makes sense, it's secure. So you check what are you including inside, what's the configuration, the Docker file, if you're using an unprivileged user to run the software, what access has those containers, if they have access to volumes that shouldn't be having, things like that. Also, you verify the supply chain of those container images from the very moment that they are built in your CI server through the registry down until they are run, scheduled and run on your Kubernetes nodes. And probably you might be doing some vulnerability management as well, using some image scanning software to look for known vulnerabilities inside those containers. So you might think, all right, so I have secured my infrastructure, I have secured the way I build containers, I'm done with security? Well, probably not. And there is a case to, once you have done all this, to do something on which is actually the longest period of a container lifecycle, production. So there are a bunch of different things we can do at runtime. So for example, on Kubernetes, you can configure admission controllers that they will check for specific policies on if a container can be run or cannot be run. If it's, for example, running as privilege, and you can configure a Kubernetes security policy to avoid that. If it's running as a privileged user and not as an unprivileged user, so you can, again, configure Kubernetes features for all that. We need to handle secrets properly, and secrets is the way to do it. Kubernetes provides some capabilities for doing that. But despite all these efforts, can we still be 100% secure? There are a bunch of things that we can do, actually. We can detect if a container or the application running inside the containers, they are misbehaving or they are behaving in a way that they shouldn't. We can look at the network access, but also at the file system level, at everything happening inside the container. We can look if it's running processes that shouldn't be running, if it's creating network connections that shouldn't be, or if it's trying to do a container breakout, and once an attacker has penetrated into one container, is trying to escape into the host. Finally, we need to look at forensics, but that's a different topic that we won't be covering today. I have other talks that talk about container forensics. So actually, containers and microservices, they are an opportunity to do anomaly detection in a better way. Traditionally, doing this has been really hard. Like, how do you do anomaly detection on an application that does 100 different things at the same time? But with microservices, we have containers that they have typically one process. It's isolated. It's doing one thing and only one thing. So it's very easy to create a pattern of behavior of what that specific microservice or container should be doing. So something that traditionally has been really hard with microservices and containers, it's going to be easier. Also, we have that idea that containers are immutable, and that's true. That's for container images. But once the container starts to run, we can, as we are working inside, we can mess around basically anything, especially if we are reading those containers as read. So we need to take care of what's happening at runtime. What kind of things we can solve with anomaly detection? Well, zero-day vulnerabilities, security issues that there is no CVE for those. Or if it's in your code, it's not a public vulnerability, so we can try to prevent those. Wrong configuration. What happens if I just open my service with any authentication? Leak or weak credentials. Internal malicious activity, someone SSHing into a production server, doing Docker exec or kubectl exec, and starting to mess around. Those are examples of things that they are happening at runtime, and that cannot be prevented using other different measures. So now that we understand why runtime security and anomaly detection is important, let's look at how Falco can help. First of all, I would like to re-announce, probably because we did a couple of months ago or weeks ago, Falco, it's now a CNCF Sandbox project. That means that we are opening even further the development for anyone who wants to contribute. CNCF is hosting us, empowering to communicate and talk about the project like here today, and giving support in other different ways, which is awesome. Basically, for those who you don't know Falco yet, Falco is a runtime engine to detect anomalous behavior inside containers and also hosts. Basically, audits all the system activity and compares that system activity against a pattern, a set of rules. If something it doesn't match, we'll trigger an event, an alert, and we'll take it from there. So if you want to know more about the CNCF announcement, I have included a blog post there. But as I said, basically Falco is going to help you to audit and detect everything that a process and therefore a container in your system does. It uses Sysdig flexible rule mechanism, which is very similar to TCP-DUM. So if you have used TCP-DUM before, the way you create those rules, those filter expressions, it's very similar. We'll see in a moment. But what makes Falco very special, especially in this context, is the way we support or we work with containers. We support Docker, Rocket, LXC, and other container formats as they get broader adoption. And we support orchestration platforms like Kubernetes, but also others like Mesos or Swarm. So you can bring all that knowledge, all that context that only you have on your orchestration tool into Falco roles. And basically Falco, that's everything it does. We match system behavior, container behavior against a pattern, and if it changes, we'll send an alert. What you do with the alert, it's your own business. Obviously, we are proposing some examples or some solutions that you can do, and we'll see in a second. But sending files, sending alerts to files, logging systems, or piping into different programs are things that you can do. As I mentioned before, Falco, it's open source, so you can install it, contribute to it, break it, or improve it. Installing Falco, it's as easy as installing a package, or if you want to install it the way it shouldn't be installed, using the bash one-liner. It's also available as a Docker container, but probably today, if you're here, it's because you're running Kubernetes, so you can deploy it using a daemon set, or even in a way easier way, using Helm. So we have a Helm chart, which is just one-liner to install Falco. And how does Falco work under the hood? Falco leverages Sysdig visibility engine, which is also open source, to hook into the kernel, either using an eBPF proof or using a kernel module, depending on your kernel version and where you are, to capture all the system calls. And from the system calls, we are going to gain observability inside the containers. We can use those for metrics, but in Falco, we use it for security observability. And some people who are not very familiar with the low level might be thinking, oh, how can I use system calls? That's very low level. I'm not familiar with it. Don't worry. You don't need to be familiar with the low level areas of the kernel to use Falco. So to give you just a clue or a tip of how this works, if we see clone or exec-v system calls, that means a new process has been spammed, a new command has been executed in the system. If we see open, close, read, write system calls, that means that there is some kind of file I/O activity. Maybe it's file system, maybe it's network activity. If we see accept or listen or connect or socket system calls, that means that there is some kind of network activity. There are a number of runtime security tools, like Linux capabilities, Seccomp, Parmor, Linux, but Falco provides a different use case. If you are a little bit familiar with Seccomp, it's great. Seccomp basically allows you to create either a whitelist or a blacklist of system calls that you can execute on your containers. And definitely there are some system calls that you don't want to be running a container, like shutdown. You don't want a container to shut down your system, your node. But it doesn't give you any additional context. For example, a chmod in /var/lib/whatever might be okay, but doing that on a binary or on a configuration file might be an undesired behavior. So with Seccomp, we don't have that context. Linux or a Parmor, they are way more complete. They have that higher level knowledge of what's a file or what's an IP address, what's a port, but they don't have any knowledge about containers. So you cannot say, oh, this is a privileged container, or this rule, it's applied into this specific deployment. There is no knowledge for that. So Falco was created for that. And some of you might be thinking, well, if it's only alerting, it's okay, but actually I want to block, I want to block my attacks. My value is on blocking the attacks, not just alerting. And I'm going to use the home security analogy for this. So when you don't want thieves to steal at home, basically you put lock on your door, you put Windows sensor in your windows, so you make sure they are not left open. You put even exterior cameras. So basically you prevent people from breaking in. But if you implement all those security measures, I'm pretty sure that you also have motion sensors inside of the house. You have security cameras inside of the house. So despite implementing those outside measures or layers, it's also very important to make sure if those attacks are successful or not, or what's happening inside of the house, because it's what really matters. If a thief walks by your street, well, probably it's nice to have, but you want to know if they actually are broken in your house. So with software, it's probably the same thing. We are doing authentication, we restrict access and privileges, we fix software vulnerabilities, and all that's awesome, and we should do it, we need to do it. But we need to make sure if the attackers make their way into our house or not. And this is where Falco is very useful. We can detect, audit, and detect what's happening inside your container and your software. So this is Falco architecture. Basically, we capture all the system calls at the kernel level, and we copy them into a user space process. We put all the system calls through some filtering, and then we create different alerts sending to different places based on the Falco rules. As I mentioned before, what makes Falco very different is that all these system calls, they are coming in context with Kubernetes metadata. So I can say, give me all the system calls coming from this namespace or from this pod. We have that knowledge. So to give you an idea of what's a Falco rule look like, it's something like this. It's YAML, where you can basically define a few things and you define a condition, but let's get into the details. First of all, you shouldn't worry too much about creating hundreds of different rules. Falco ships with out-of-the-box nice rule set, and we have created default rule sets for the top 10, 15 most popular Dart Hub projects. So if you're using things like Apache, Nginx, Elasticsearch, Kubernetes components, we have default rule sets for all that. But if you still want to customize or modify them, basically you're going to see yourself leveraging macros lists to create rules. And the magic of the rule, it happens at a filtering expression. We are going to filter for system calls that shouldn't be happening. The way we create these system rules, or filtering rules, sorry, as I said before, it's very similar to TCP/dump. We support container and orchestration tool logic in those filtering rules, and it's basically a huge OR that we are building in the engine. We can use what we call field classes to look for information coming from system calls at a higher perspective. So we can look for container metadata, Kubernetes metadata, users, file descriptor activity, system log messages, a bunch of different things. So to give you a few examples, because what's really interesting, if we want to detect if a shell was running into a container, we can do something like this. Container is not the host, and the process name is something. If we want to see if a process is overwriting system binaries, we would create a rule like this. If a container is trying to change its execution namespace because it's a privileged container, we can do something like this. Or maybe you want to deploy Falco in your desktop and create a Falco rule to detect if any kind of malware is trying to open your webcam. Once we detect these anomalous patterns, we will send alerts into different places. Standard output, your login system, but we can do more interesting things. So this is the entire skeleton of a Falco rule, where we put like a name, a description, and this is the magic. So here we are looking for new processes executed on containers, which container image starts with node, and the process name, it's not node. Okay, this is very simple rule. But you get the idea, the kind of things you can create. Now, a real example. So typically, you deploy applications on Kubernetes and they store sensitive data like passwords on secrets. If those secrets, they are read when the application is started. If something goes south and your application gets hacked, your container gets hacked, and suddenly the container starts reading those secrets again, 5 seconds after the application was started, probably there is something wrong happening there. So this is a rule that detects if a process that has been running for more than 5 seconds reads the secrets mounted in the pod again. So, and now I wanted to announce a new feature which is coming on the latest version of Falco, which was released yesterday. I don't know how many people know Kubernetes Audit events. Basically, it's a feature new on Kubernetes 1.11, and basically provides a way to understand any change made through the Kubernetes API server. Those events, they can be sent somewhere else. So Falco now has a small HTTP web server when we can receive all those events, and they look basically like this. So a specific user, it's deleting something, or it's allowed to delete something in that namespace. So basically, we implemented a generic event interface, and then we created a specific interface for Kubernetes audit events. So now we can create our rules based on all the information coming from here. Tomorrow, there is another session that I'll get deep into the details of creating event interface on Falco, so you can filter all the things apart from Kubernetes audit events. But again, because with an example, we understand things better, this is one of the very cool things you can do ingesting kube audit events in Falco. So if someone tries to deploy a config map that includes a secret, that they shouldn't be doing. They should be using a Kubernetes secret for that instead. We can basically audit that on runtime and generate an alert, an event. So this is the entire filtering code that you would have to use in Falco for that. It's going to be included in the default rule set. So, okay, so Jorge, all this sounds very interesting, but how do I use Falco on my organization? So Falco needs to run together with some other software, either some alerting software, some logging software, and hopefully you can also implement some response software together with Falco. The idea is Falco will detect anomalous activity. We will publish the event, the alert somewhere. You have different other security software or other software components to subscribe to those events and react. And we can do very cool things reacting to Falco events. We'll get into some examples in a second. Basically, this is the idea. We have Falco, and we created a reference implementation using cloud native software. So we can have Falco events sent into NATS, which is a message broker. And then we can use Kubeless, which is a framework as a service, functions as a service framework that integrates nicely with Kubernetes to react to those events. In this blog post, we wrote about it in deep. And this is the entire response. So basically, there is a sidecar container that publishes events into NATS. Kubeless functions, they subscribe into the different topics, and depending on the topic and the priority, we can trigger different reactions. So we can send a notification into Slack or PagerDuty, whatever it is, or we can react, make a change, like kill the pod, isolate the pod, etc. There is also another implementation based on AWS services using Amazon SNS and Lambda, if you're interested into that. And what's really interesting here, and I'm really passionate, is how we can leverage functions as a service to respond in a very fast, dynamic way to our security events in our containerized infrastructure. The idea, functions as a service, they are very small, short, easy to understand, straightforward pieces of code. And traditionally, on DevOps and also in the security world, using playbooks has been the most standardized way to respond either to an incident, an infrastructure incident like a service going down or a performance problem, but also to a security problem. If you as an operator load a playlist and you know what you need to do, well, why you don't automate that response as a functions as a service? So you can delete a pod and Kubernetes will create a new one, or you can isolate that pod with a network policy, you can log, you can create an alert, or you can take a Sysdig capture, record all the activity, and then do forensics and postmortem analysis. Same thing if you're trying to create a SIEM. So if you're trying to send all these security events into a login system and create nice dashboards, same thing can be done with Fluentd that can record or forward all the Falco events into Elasticsearch or other login database and use some dashboarding tools like Kibana to create reports about it. This is how it looks. And if you want to know more, and I don't know what's my timing because we started late and it was a little bit messed up, but please have a look at the website. We have a Slack channel, and at the Sysdig blog, we often write about Falco. So we have a bunch of nice blog posts there as well. And since we have 5 minutes more, we have some time for questions. Yeah. Hold on, there is a microphone coming for you.
Does it support kind of image tagging, or is it out of
So at the moment, Falco, it's basically focused on runtime security. There are other both open source and commercial tools for doing image scanning. Sysdig Secure, which is the commercial product that we have built on top of Falco, includes image scanning. There are other image scanning tools that they are open source, like Anchor or Claire. But they are different aspects, different layers. We are exploring on different ways to integrate both sides of the container scheduling processes. And for example, the commercial product can scan images that or can rescan images that previously were validated, but now because they are in production and there is a new CVE, we can re-trigger scans. So we are exploring into different ways, but right now, Falco is just runtime. No more questions? So tomorrow there is a deep dive session which will go into more of the inside details of Falco and on how you can do things like the response engine in detail and how you can implement your own auditing interface for events coming from other places other than the Kubernetes audit system. Thanks very much for coming. I'm around, and let me know if you have any other question. Thanks.